This is unit 3, where we're going to bring all the information together and look at actually graphing the cubic functions. So we're going to go through finding y-intercepts, finding x-intercepts, finding point of inflections, and then we're going to graph it. In this course, I think I've said this before, in this unit so far, you will not be required to find turning points of anything bigger than a quadratic. Okay, we'll do that later in the year with differential calculus, but as of yet, you are not expected to know how to do it. So we're going to start off with the easiest one, finding the y-intercept. And this is the same as linear, this is the same as quadratic, this is the same as quartic. Okay, so the y-intercept will always be when x equals 0. Okay, so we kind of know from previous units that if we make these 0, so 0 cubed plus 2 times 0 squared minus 0, the y-intercept is going to be the constant of the end. Okay, so whenever it's expanded out like that, the y-intercept is the constant. Okay, it's a little bit different for these ones, just because they're not expanded out. There's two different ways we can approach them. We can expand this out into this format and then get the constant off the end. That's an option. Or probably the quicker way to do it is to sub 0 in for x. So let's try that one. So y equals, wherever I see an x, sorry, I'm going to put a 0. Okay, so -1 cubed is -1. Y equals -2 plus 3. So the y-intercept's at 1. Okay, so it's not that one there. That is part of the point of inflection, but it is not the y-intercept. So just be careful with that. And this last one here, you've got the same options. You can expand it out into expanded form and then look at the constant if you want to, or the quicker way is to sub 0 in wherever you see x. Okay, so that's what I'm going to do. 0 minus 1, 0 minus 2, 0 minus 3, which gives us -1, -2, -3. Okay, -1 times -2 is positive, 2 times -3 is -6. So the y-intercept is at -6. Okay, shortcut for that, you can just times the numbers together up here. And -1 times -2 times -3. So you can expand out if you want to, but just remember it's often quicker to put in 0 for x and solve that way. So the next part is point of inflection. Now in this course you will be given either a cubic in power function form like this, or you will be given it in expanded form like that. Okay, so if it is in power function form, that is when you will find the point of inflection. You won't be asked in this course to find the point of inflection if it is in expanded form. Okay, so point of inflections is on your formula sheet, and it states that when the function is in this format up here, the point of inflection is h, k. So the only trick to this one, you've got to do the opposite sign here. So the point of inflection is at opposite sign 1, 3. Okay, and this one over here, point of inflection is at -5, -2. Okay, so when we're graphing from that power function form, you can have a look at your formula sheet, but all you need to do is change the sign of the one in the bracket and have the one outside the bracket with the same sign. So that's pretty simple. Where graphing cubics gets a little bit harder is with the x-intercepts. Kind of same as the quadratic functions. When we're trying to factorize, it gets harder. So there's two types of strategies we're going to use. The first one is when it's in expanded form or factorized form, and we're going to use a different strategy when it's in power function form. Okay, and the reason we're going to do that is these kind of functions, they might have 1 x-intercept, 2 x-intercepts, or 3 x-intercepts. This type of function will only ever have 1 x-intercept. Okay, so this one we kind of have to have a look. The other one we know it's only going to have 1, so they're different techniques. So same as with quadratics, we are going to use the null factor law. So if we're looking for the x-intercept, we're setting y equal to 0, and the null factor law tells us that each of these brackets has to equal 0. So therefore, I've got x-intercepts at 1, 2, and 3. Okay, same process as with quadratics. Over here, we've got a little bit more work to do, simply because we don't have it factorized. Okay, so the goal is to get it factorized and then use that null factor law, same as we did there. I need to remember all my steps for this one, and the first thing I need to do is find a factor. Okay, and I'm going to do that by trying a couple of different factors, subbing them in for x, and trying to find one where my function equals 0. Now what we're looking for is factors of negative 24. Okay, it's going to be one of those. So it could be 1, it could be 24, it could be 2, it could be 12, it could be 6, it could be 4, it could be 8, it could be 3. And it could also be negative 1, negative 24, negative 2, negative 12, negative 6, negative. Okay, so there's a lot of factors. You could try all of them. Okay, in this course though, it is normally going to be 1, negative 1, 2, negative 2. Okay, it's going to be a little number. Because you have to cube it manually, they're not going to give you 24 in a test and expect you to cube it in your head or on paper. Okay, so just be aware that's how we find the options to sub in, but it is pretty much always going to be one of the littler ones. So I've done this one just so you didn't have to listen to me calculate things, and I found the factor was negative 2. So f of negative 2 equals 0. Therefore, x plus 2 is a factor. Okay, so I've got one factor there. I've got one x-intercept at negative 2, but I need to find the others. So I'm going to use synthetic division to factorize the rest of this. So I'm going to put negative 2, 1, 3, negative 10, negative 24. You don't have to use these boxes, but you can if you want. Bring the 1 down, negative 2, 3 take 2 is 1, negative 2, negative 12, positive 24, 0. If you get to there and it's not a 0, you've either picked the wrong factor or you've done one of these calculations wrong, so go back and check. Okay, and that gives us x plus 2, x squared plus x minus 12. Okay, this one here, I can kind of see straight away it's going to be plus 4 and minus 3. But I'm going to show you how to figure out if you've got one x-intercept, if you've got 2, or if you've got 3. Okay, so what you're going to do is you're going to have a look at your quadratic function here. Okay, because we've already got one factor. We know there's one x-intercept, but from this quadratic function, we're going to try and figure out if we've got no x-intercepts 1 or 2. Okay, and we do that the same as we would in our previous unit by using the discriminant. Okay, b squared minus 4ac, and that will tell us how many solutions this quadratic will give us. Okay, so if the discriminant is greater than 0, it'll give us 2 solutions, plus this one will give us 3 solutions, 3 x-intercepts. If the discriminant is equal to 0, it'll give us 1 solution, plus this solution here, 2 solutions. If the discriminant is less than 0, then that quadratic there doesn't give us any solutions. So this one here is the only one we've got. Okay, you can run that discriminant every time, but for one like that where it's very, very quick to factorize, you can go straight to there. Okay, but just be aware, the discriminant is how we figure out how many solutions that quadratic function is going to give us. Okay, now this changes a little bit. So we know that when cubic functions are in power form, that they are only ever going to give us one x-intercept. So we're actually just going to rearrange this to find the x-intercept, because there's no point factorizing because we know there's only going to be one. Okay, so I'm just going to rearrange it. I'm going to start off taking 2 from both sides. Okay, then I'm going to divide both sides by 2. get rid of that cube, it's a cube root. So cube root of -1, which is just -1. Okay, and add 2 to both sides, so x equals 1. Okay, so we only have one x-intercept and it occurs when x is 1. So they're a little bit different. Just be aware if it's in power function form, you're rearranging. If it's in any other format, you are trying to factorize. So let's bring all that together and actually draw some cubic graphs. So I'm going to find all relevant points of these ones. In a question, it might ask you for relevant points. It might just ask you for the x-intercepts. It might just ask you for the y. It might ask you for a point of inflection, or it might just ask you to sketch. Okay, so I'm going to find all points. Make sure you read the question carefully in any assessment piece to make sure you understand what they're asking you. So the first thing I'm going to find, because it's nice and easy, are my x-intercepts. Okay, and because it's already factorized, I know they're at 1, 2, and 3. Okay, the next one I'm going to do, I'm just going to underline that, make it really clear so it stands out from all my other working that's about to happen. My y-intercepts occur when x equals 0. So it's going to be -1 times -2 times -3. Okay, so y-intercept is at -6. Okay. This is the same example we used before, so just be aware of that. So I've got my x-intercepts, my y-intercepts. It's not a point of inflection because it has 3 x-intercepts. I don't know how to find turning point yet because we haven't learnt differential calculus. So that is all the information that I have so far. Okay, I'm going to draw my Cartesian plane. So any sketch, we need arrows on the end, x and y's. Okay, and I'm going to mark through my x-intercept. So we've got 1, 2, and 3. And my y-intercept is at -6. Right down here. Okay, I'm then going to have a look and see whether I have a positive graph or a negative graph. So if I expanded this, I've got positive, positive, positive. I'd have a positive x cubed. Therefore, my graph's going to have that shape. Okay, so I'm going to go up through here like that. Right, and I'm also going to label everything. So I've got x-intercepts at 1, 2, and 3, and a y-intercept at -6. And that's my graph. Okay. So the next one's a bit more difficult, and it's also quite typical of what you'll be asked. So we're going to sketch the graph of this function. All right, so we're going to go through by bit. For this one, the easiest point to find right there is the y-intercept at -24. Okay, so even if you get to one of these questions and you get really, really stuck, you might be able to find 1 or 2 bits of the information they ask for and get 1 or 2 points out of the total. All right, we need to find our x-intercepts. Okay, so we need to factorize it. And we did this before, so I know that -2 is still going to be a factor. 1, 3, -10, -24. You don't have to use this box. -2, 1, -2, -12, 24, 0. Okay, see how much working went on there? That's why you need to underline and make really, really clear where your answers are. If a line still isn't clear enough, put a box around it. Okay, so we've got our y-intercept, we've got our x-intercepts. Our x cubed is a positive, therefore the graph's going to have that kind of shape. There's no point of inflection because it's not in turning point form, so we're ready to graph. So Cartesian plane first, put in all your information. Okay, and I'm going to start with my x-intercepts. So we've got -2, 1, 2, -4, and +3. Okay, we've also got a y-intercept at -24. Didn't draw my graph big enough, put it down there. Okay, so it's going to go up like that. Okay, and we need to label as well. So -2, -4, hopefully yours is a bit neater than mine, 3, and -24. Okay, so that's a pretty typical question that you'll be asked. So we're finding x-intercepts, y-intercepts, is it a positive or a negative? And that's for that format. When we're looking at our power function form, we're still going to be finding the same kind of points. They're just going to vary a little how we do them. So we'll start with our y-intercept. We'll start with point of inflection because that's the easiest one to get. So point of inflection is at HK, so 2, 2. Okay, our y-intercept is when x equals 0. So y equals 2 times -2 cubed plus 2. So -2 cubed is -8, times 2 is -16, plus 2 is -14. Underlining to make them really clear. And we're going to have one x-intercept because it's in power function form. Okay, so I'm going to rearrange that. So x-intercept, so we're going to take the 2 across the other side. -2 equals 2. Okay, divide both sides by 2. Cube root, still -1. Add 1 to both sides. X equals 1. So x-intercept at 1. Okay, see how I've kept all my working on that side? Okay, it's neat. It's neatish. It's in an order, and my answers are very clearly defined. If you want them even more defined, okay, just make them really, really clear, especially if the question asks you to identify the x-intercepts, the y-intercepts. Make sure you've got it very, very clear. This is my x-intercepts. This is my y-intercept. Okay, and then the graph can go off the side. So my x-intercept, I've only got 1, and that's at 1. I've got a point of inflection at 2, 2, about there. I've got a y-intercept at -14, and my x is a positive, so it's going to have that shape. Sorry, it's going to go like that. So we're going up, point of inflection. We're not going to turn. I missed it. Just going to change my dot there because I missed. Okay, so it's not going up, coming back down. It's just flattening out and then going back on its way up. So my points I'm going to label if they're on the line with just numbers, so 1 and -14. And if they're hanging out in the middle of nowhere like this, I'm going to use a coordinate, so 2, 2. And that's it. Okay, so we've gone through x-intercepts, y-intercepts, point of inflection, and graphing. Okay? So if you want a bit more practice, have a look at the examples and work through them using the videos if you need to, and then have a go at the textbook one as well.